of it today and then the first half or the second half tomorrow. So you can just title it 7.7 Factoring Special Products. And then today's section is covering something called factoring the difference of two squares, which difference, like in math, it just means subtraction. So difference of two squares means like when you have one perfect square minus another perfect square. And perfect squares is just like numbers that you get when you square another number. So like 4 or like 9 or 16, those are all perfect squares. Hey, Brainer. So we just started, so I'll give you time to write down the title and then we'll get started on some of the examples. So one thing that I want to talk about before we get into the actual pattern itself is just to kind of remember and like refresh some of our perfect squares. So I'm going to make a T-chart. And then on the left side of the T-chart, that's just going to be our number. And then on the right side is going to be our number squared. So you can just call it x and x squared. Just meaning like if my number is x, and then x squared would be 1 squared, and 1 squared is just 1. And then you guys, oh, you can't see it. Sorry. Hold on. Okay. So, and then like the next number would be 2. And then 2 squared would give you 4. Next number 3. 3 squared would be 9. And we're just going to go all the way down to 10. So 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. And then 9 squared is 81. And for 10 squared is 100. So those are just the first 10 perfect squares. You probably remember maybe like 121 is 11 squared or 144 is 12 squared. If you're ever not sure about like if something is perfect square, you have a couple of different options. Like you can square root it on a calculator and see. So if I do, there's a square root button on most calculators. If I type like the square root of 121, I get 11. You can also Google just like perfect squares and it'll give you a list. If you're not, like if you don't really remember them, it's totally fine. I would just like Google and kind of give yourself a list that you can go back to when you work through some of the assignments. So now the difference of two squares pattern is if we have a squared minus b squared. So just one perfect square minus another perfect square. This factors into a plus b times a minus b. So now it's in factored form, and that just means it's written as some like numbers being multiplied together now instead of just the difference. And it's not just really by like chance that it works out this way, because remember, whenever we factor, we can check our answers by foiling. So if we foil this pattern, a times a, that's a squared. A times negative b, that's negative ab. B times a, that's positive ab. And then b times negative b, that's negative b squared. So this negative AB and positive AB, since they're the same number really but opposite signs, they just cancel each other out. And that'll always happen when you have something that factors into that pattern a plus b times a minus b. You'll end up with the same two numbers in the middle, like when you go to FOIL it and check, but those numbers in the middle cancel each other out. And then we're just left with a squared minus b squared. So for example 1, so just factoring the difference of two squares, and then we're going to factor for a x squared minus 25. So you may not have to do this forever, but like while you're first learning the pattern, I would always get in the habit of like rewriting it as like what is being squared. So what I mean by that is x squared, that's just obviously x being squared. But 25, that's 5 being squared. So I'm going to write it as minus 5 squared. And then from there, now we can see that, okay, my a from this a squared part would just be x. And my b from this b squared part would just be 5. So a would be 5 and a would be x and b would be 5. And then we plug those into this pattern, a plus b times a minus b. So a is x, b is 5, and then a plus b would just be x plus 5, times a minus b would be x minus 5. So x plus 5 times x minus 5. And remember, especially when you're like learning new things, it's always good to check it just to make sure you're doing it correctly before you get into into any wrong habits. So if we want to check it, we can just FOIL. So I'm going to rewrite it up here, x plus 5 times x minus 5. And then x times x, that's x squared. X times negative 5, that's negative 5x. 5 times x, that's positive 5x. And then 5 times negative 5, that's negative 25. Whenever we FOIL, we're supposed to check for like terms. So this is a negative 5x and a positive 5x that are both x to the first power. So we can combine them, but negative 5 plus 5 is 0. So they just cancel each other out. And then we're left with x squared minus 25, which is what the original problem was, so we know we did it correctly. And then for b, so 4z squared minus 1, whenever you have a number in front of the variable, it gets a little bit tricky because as it's written right now, this 2, like the squared, is only belonging to the z. So it's like 4 times z being squared. So I can't just really say like a is 4z because that 4 is not being squared also. But I can take that 4z and I can rewrite it as 2z in parentheses squared. Because that goes back to the properties that we were learning like at the very beginning of class. It was chapter 6 when we learned about exponents, where when you have a product inside the parentheses, that product or both factors of the product get that exponent. So you don't have to write this next part, but this like 2z in parentheses squared, that would be 2 squared times z squared, which that 2 squared turns into 4z squared. I'm just going to move this to the side in case anybody prefers to have it on there just as a note for themselves. Oh, I can't move it. I'm just going to rewrite it up here then. So this 2z in parentheses squared is 2 squared times z squared because that squared goes to both, and then 2 squared is 4, and z squared just stays the same. And then for the 1 part, like 1 is just 1 squared. 1 is 1 to any power. So we can rewrite that as 1 squared minus 1 squared. And then now we can see what our a and b should be. So a is 2z, the part that's being squared, and then b is 1. So as soon as you know what a and b are, then you can plug it into this a plus b times a minus b pattern. So a plus b would be 2z plus 1. And a minus b would be 2z minus 1. So 2z plus 1 times 2z minus 1. And then just to do one more check, Remember, you can check by foiling. So 2z times 2z, that gets us back to 4z squared, which that was our original first term, so that's good. 2z times -1 is -2z. 1 times 2z is positive 2z. And then 1 times -1 is -1. We want to check for like terms, which are -2z and positive 2z. -2 plus 2 is just 0, so those cancel each other out. And then we bring down the 4z squared minus 1. And that's our original problem, so we're good. So the difference of two squares is, like I said, it's a kind of pattern that you look for when you're factoring. Whenever you have three terms, like a trinomial, that's when you want to use the x method. But if you have two terms, then there's two different types of factoring that you can really check for. One is a difference of squares like this pattern, and then one is just greatest common factor like that very first section that we talked about when we started this chapter, where you can only pull out greatest common factor and nothing else. So I'm going to give you guys time to do A, so x squared minus 36. It's really similar to the A up here. Just the only thing that changes is the 25 to 36. So I'll give you guys a minute to work through that, and then we'll go through it together. If you work ahead, I want you to keep in mind that A always has to come from like the first term, and B always has to come from the second term. It's not like A is always the variable part. I'll tell you more about what I mean in part B. For A, so I have x squared, that's just x being squared. What can I rewrite 36 as? Julia? Yeah, perfect, minus 6 squared. And then A would be x, B would be 6. And after that, it's just a matter of plugging it into this like A plus B times A minus B pattern up here. So A plus B is x plus 6. A minus B is x minus 6. And then for B, I want to talk about, because it's like, it seems straightforward enough, but there's a kind of a mistake that gets made sometimes when the like number part comes first before the variable part. So what could I rewrite the 100 as? 10 squared? Yeah. So 100 I can rewrite as 10 squared and then minus m squared. So since we're comparing it to this like A squared minus b squared pattern up here, that means that a always has to be the first part. So a would be 10. And then b always has to be the second part, so b would be m. It's not necessarily like a is the variable and b is the regular number. It just depends on the order itself. So a is the first one, b is the second one. So if a is 10 and b is m, then it would be a plus b would be 10 plus m. And then a minus b would be 10 minus m. And that's something to where if you did do a different order, like if you did do like m plus 10 times n minus 10, if you checked it, that check would not be your original problem, so it would be a way of checking yourself. Okay, so I want to talk about how to get started for C, and then I'll give you guys time to finish the last two. For C, 9n squared minus 16, how could I rewrite that 9n squared though? Because the 9 isn't being squared right now, just the n. Yeah, good job. Yeah, so 3n in parentheses squared, because now that's written as like 3 squared, which is the 9, and then n squared. And then minus 4 squared, or sorry, minus 16, so minus 4 squared. And then our A is 3n, our B is 4. So I'll let you guys finish that problem and then work on D also, and then we'll go through that final answer and then D once you guys are done. And then if you guys finish C, you can move on to D. Raphael, did you get the final answer for C? What'd you get? Oh, for D? That's really, it's okay. That's really close. One thing I want to say, what is 6 squared? What's 6 times 6? So it should be 4. Yeah, it's okay. That's an easy mistake, especially if it's going to 16. Did anybody get the final answer for C? Julio, did you get it?
Yeah. Is it parentheses 3n plus 4 and parentheses 3n minus 4?
Yep, that's good. Good job. 3n plus 4 times 3n minus 4 for C.
Yeah.
Because this is our, it's just basically we're plugging into a plus b times a minus b, and then a was 3n and b was 4. Good job. Okay, so Raphael, what did you rewrite 16h as for D? Good job. Yeah, 4h plus 7 times 4h minus 7. And that's because 16h squared is 4h in parentheses squared, and then 49 is 7 squared. So our a is 4h, our b is 7. So this is our a plus b, 4h plus 7, and a minus b, 4h minus 7. Okay, good job. So that's it for the notes. That's the only topic that we need to cover today. So now it's